Hello everyone. I Miss Pooja Patle, Assistant Professor Tulsiramji Gaikwad Patil, College of Engineering, Nagpur. In today's session, we'll see about debugging in software. In software testing and quality assurance subject, debugging is one of the topic and how it works, what does mean by debugging, we'll see in this session. So, debugging is finding and solving problems in software. Whatever the problems come up with the software while testing. So, finding and solving these problems in the software is known as debugging. The programmer, after a program failure, identifies the corresponding fault and fixes it. The process of determining the cause of failure is known as debugging. What is the cause of failure? Why the software fails? What is the reason behind that? So, the process of determining the cause of the failure is known as debugging. Debugging occurs as a consequence of a test revealing a failure. Mayors proposed three approaches to debugging. So, what is debugging? Bug and debugging are attributed to a discovery of a moth found in Mark II computer at Harvard University. Debugging is not troubleshooting. These are the debugging rules. As you can see here, the first one is understand the system, then make it fail. Third one is quit thinking and look. Fourth, divide and conquer. Fifth, change one thing at a time. Sixth one is to keep an audit trail. Seventh one is check the plug. Eighth one is get a fresh view. And the ninth one is if you didn't fix it, so these are the debugging rules. Debugging is a simple method from starting to end, from start to end. The first one, a method consists of the following steps like first to start, then another one is construct a hypothesis, then construct an experiment, hypothesis proves go to B, and need more evidence go to C, and then it will stop. So this is the very simple method of debugging. Now we'll see each and every rule in detail and the procedure so that you will understand the main method of debugging. So understanding the system, how we'll understand the system? Know the fundamentals of the system, understand the frameworks involved, read the APIs and communication interfaces, know your tools, understand what each module of system does. So first we'll know the fundamentals of the system on which the system works. Then understand the framework involved. Which are the frameworks involved in the system? Read the API and communication interfaces. Know your tools. Which are the tools we are using for debugging? Understand what each module of the system does. So, analyzing, understanding the system is a basic method for debugging. The second one is make it fail. Now, start at the beginning, automate the failure. No detail is insignificant. Intermittent failures, isolate the failure, and build debugging tools and test harshness. Quit thinking and look is the third step, where we gather the low level details and see the failure. Understand the context of the bug. Design instrumentation in runtime statistics, which are the instrument we'll use in runtime. The status messages, debug logging, be descriptive. Deployment time environment checks, hypothesis and test. So, a programmer or a tester should think about these points so that it will understand the context of the bug. Fourth one is divide and conquer. Narrow the search down software and hardware. Successive approximation. Start at the bad end, example the error log, and work your way up the chain looking at the various points on the way. Now fix the bugs you know about. Fixing one could fix the other. Fix the noise first, but don't go nuts. So, this is the divide and conquer method. Another step is change one thing at a time. So, for that, compare with a good one. Use a rifle, not a shotgun. What's changed recently? It used to work. Then separate environment and product. Now keep an audit trail. It is the sixth step. Keep a day book of what you did. During debugging, write down what you did, in what order, and what happened. So, what you're doing, in what order you're doing that thing, and what happened during doing this. So, these all the one should write down. Be specific and consistent. Correlate symptoms with others. Version control and change logs are great for determining and a method changed. Then check the plug. Here, question your assumption. Get a fresh view. Get another viewpoint on the solution. Talk to somebody about the problem. Ask an expert about ask an expert. What? Email the author, check the forums, subscribes to the mailing list. Make sure you report symptoms, not theories. And the ninth one, if you didn't fix it, it ain't fixed. The most important lesson by far, fix the root cause. Make sure it can't possibly happen again. Fix the process at fault. We didn't see an issue until we deployed into the production environment. So, while using the system by user, and he came up with the errors or faults. So at that time, we didn't see an issue until the deployed into the production environment, so that the faults should get fixed at early stage before launching the software. And now here are some debugging methods and tools. In debugging methods, sprint trace debugging. Watching the flow of execution after adding print statements to the original code. Remote debugging. Connect to a remote system with a debugger. Monitor the execution and state. Post-mortem debugging, where analysis of a memory dump from a program that has crashed. And then profiling, not debugging but a useful technique for analyzing a running program to look for issues. So this is all about debugging process. What is it? It is the finding and solving the problems in software. So that's how debugging works. These are some methods we learned from this session. So the programmer, after a program failure, identifies the corresponding fault and fixes it. So the process of determining the cause of failure is known as debugging. Debugging occurs as a consequence of test revealing a failure, Mears proposed of debugging. So this is the concept of debugging. I hope you all are understood. Thank you so much.